Hello everybody, today is day 15 of the Advent of Code puzzle challenge, and today's puzzle is about moving warehouse stuff around. So over here you're in some kind of submarine, and there are lantern fishes who are gathering their food, and they are storing it in a warehouse. And over there is one robot that is working over there in the warehouse, and you need to control and predict where the robot is going. So the lantern fishes gave you the data about how the warehouse looks and the instructions where the robot is moving. So something like this. And the robot can only move if there's no obstacle to the movement side. If there is some good that this good is getting moved, but if there's obstacle on the way, then the robot is not moving. So so at first you have the map of the warehouse, and then you have instructions where the robot is moving. So so let's get some example. If we have this kind of example that this at symbol represents where the robot is, and below there are instructions. So if you have this kind of initial state, then if you move to the left, there's an obstacle, so robot does not move anywhere. Then you move up, then the robot moves up. Then if it moves again up, then nothing works. Then he moves to the right. He moves the food. Yes, more right, nothing happens. And then it moves down, moves left, it moves down, it moves right, it moves right, it moves down, it moves left, and nothing happens now. And so here is how the larger example looks like after all the moves had been over there. And in the end, you just have to multiply. You have to sum actually the going things downwards. You have to multiply that by 100, and to the right side, you have to just take the index of all the goods that are over there. So that is a goods positioning system. So this was the puzzle. The first part was actually easier one. The first puzzle was not that hard. So I solved it. How it was? You just take the everything that's in the input. You also check has got to commands. If it's just like a new line, then you take the commands. Else you just store it to some grid element, and then it's quite a huge make move method. But before you jump into the make move method, you just 4 characters in command. You just make a move, and you store the x and y coordinates of the robot. And inside the make move method, make move, you just store the y and x coordinate by dy. Yes, because we do not want 4 methods, like for one method for x, like one method for moving up, moving down, moving left or right. You don't want that. It's gonna be a cumbersome. So you just have dy and dx. And so if this new position is where the robots have to go, if it's just an obstacle, then you don't do anything. If it's a free space, robot is going there, and the current place is just replaced with an empty space. And then you also store the new values for the you store the new coordinate values. And if there is good over there, then there is more magic. So what it is, it's still so you have to also take to the consideration some count, and if there is after the O, if there's an obstacle, then you just return, nothing happens. And if it's after the obstacle, if there's a dot, then what I did, I just did so that the last point will get the O, the first point, the robot thing does just empty place, and the last index in that list, it gets the new robot position. Yes, so this is it. It was part 1. It was not that hard. Actually, I finished it, I think something like in 30 minutes or something. Yeah, so this is how it was, and got the answer. But now for the part 2, the part 2 was a lot more difficult. For part 2, it was that the lanternfish use your information to find a safe movement to swim in and turn off the malfunctioning robot. But they gave you a second warehouse, which is surprisingly similar to the first one, but it was that it's a lot more bigger, especially in horizontal direction. So you have to replace, if the tile is just an asterisk, you replace it with 2 tiles. If the tile is O, so that you replace the good with a 2 symbol of goods. And if it's dot, you replace it with 2 dots. And if it's at symbol, you replace it with at and point. Yes, so now the map is totally different, and yeah, and yeah, so you need to check out something. Yeah, so for example, if you have this kind of map, it will go to this kind of looking, so that the goods are double the size. And then if you move them around, if you move to the left, the goods will move. Then you move 2 places down, you move left, you move left. And now if you move up, then you can see that all of the goods are moving up together with you. If you try to move one more time up, nothing moves because there is one obstacle in the way. Now if you move left, you move left, you move up, and if you move up, you only move the good in the way as it should be. And yeah, this is how it goes. And yeah, the part 2 was a lot more difficult. How I did it. So yes, first if you just open it, and if you just take the grid elements, you just replace everything that the instructions said, and then you add them to the grid. And yeah, over here is what it is. It's the end is still quite the same, but now yes, you have to make a move. Let's see how the move making goes. It starts the same. It's just like the dy is 1. Yeah. You just take the dy and dx values, and the same thing. If the coordinate is asterisk, you return. If it's just a point, you just make a move. But now it is that if it's left or right, then it's a little bit easier, but still it's trickier than it was with the part 1. You need to replace this left side of the box with the right side of the box, and vice versa. And then you have to make a move as well with the robot. So yes, the left and right was a little bit trickier, but it was managed to do. But if it's up and down, well, then it's so that you have to check whether you can move up or down, and if you can, then you can only make a move. So here what I did was that first. Well, you have to have these index systems, and you have to know how it works. first you check the availability, and if you can move somewhere, then you make a move. And so that the check availability method, how was it? It was that well, it was some kind of nested thing that you just take the first element. I can even debug it. So you just take the first element. You just how it is. So x start and x end. So you just check all the boxes one by one, and yes. So if there's just a free space behind it, then return 1. If there's a new box behind it, then we just call in the same method as many times as there are boxes. And if there is some obstacle, you just return 1, and you return -1, and nothing else happens. Yeah. So this is it, and if there is so this is like a nested loop over here. Yes. So this is how it goes, and yeah, if there's nothing obstacles around, then you just move it, and this movement it's quite similar to this check availability. Yes. So if I run it, then yeah, I got the result as well. So this is how it goes, and this was my code. Let's see the leaderboard. So today, first people who got both stars, it took them 15 minutes, and for the last one it took half an hour. So it was quite tricky. The first puzzle was a lot more easier. So my times was personal times. My time, first puzzle I solved it in half an hour, but for the second part it took almost 3 hours. So yeah, this is the puzzle. I hope you liked the video, and yeah, let's see you next time.